In this video, we're going to look at work integrals. A constant force acts in a direction of motion of an object through a distance d. We define the work done on the object to be work is equal to force times distance. This is a formula we apply when we have a constant force acting on an object over a distance. In this question, we have a 1,000 kilometer car is being lifted vertically by a crane to a height of 10 meters. Find the work done by the crane. So we're in the metric system, the SI metric system. The mass of the car is 1,000 kilograms. The distance traveled vertically is the distance d is equal to 10 meters. And gravity, of course, is 9.8 meters per second squared. Work is equal to force times distance. The force is mass of the car times gravity, mg, this part is a force, times distance. Mass of the car is 1,000 kilograms, gravity is 9.8, and the distance is 10 meters. So the work done, let's multiply all of these numbers, and we get 98,000 joules. So this part, this is the mass, this is m, 9.8, this is gravity, that's g, and 10 is the distance traveled by the car, that's d. All right, so joules is a unit of work. So joules is equal to 1 Newton times meter. So when a 1 Newton force acts for a distance of 1 meter on an object, the product, we call it a joule. 1 joule is 1 Newton meter. Let's look at another example. Here we have how much work is done in lifting a 200-pound metal bar 100 feet off the ground. Now in the US system, pound is already the weight of the object. It's already a unit of force. This is already a unit of force. So it already includes gravity. Work is equal to force times distance. The force is 200 pounds. And the distance is 100 feet. Multiply, we get 20,000 foot-pound. So let's do a summary of the units that we're applying in these two examples. For the SI system, the SI metric, 1 joule is equal to 1 Newton times meter. For the US system, the imperial system, 1 unit of work is equal to foot-pound. So feet times pound. I'll just put units of work. All right, now let's consider a variable force that acts on an object along the x-axis in the positive direction. And let's assume that the force varies continuously. Let me change back to this green color. So the force acts continuously, and it varies continuously as it moves the object from x equals a to x equals b. Consider an infinitesimally short distance dx through which f of x moves the object. So f of x is moving the object from x to x plus dx. In this short distance, clearly the force is approximately constant. So the work done in moving the object from the position x to x plus dx is simply the product of f of x star times dx, where x star is somewhere between x and x plus dx. Now, as this partition width dx approaches 0, the change in distance, as this approaches 0, x star approaches x, and the work simply becomes the integral a to b f of x dx. This is not a rigorous proof. A rigorous proof would involve Riemann sums, and you can look that up in in any standard calculus textbook. You'll be able to see that. But this is just the overall big picture. So the work done in moving the object from x equals a to x equals b is simply integral a to b f of x dx. We're going to look at an application of this. So when a particle is x meters from the origin, a variable force given by f of x is equal to x plus e to the minus x plus sine of pi x over 2 moves the object from x equals 1/2 meters to x equals 2 meters. Find the work done on the object. So we start by using the formula work is equal to the integral from a to b f of x dx. f of x is the continuous variable force that's being applied. A is equal to 1/2, b is equal to 2. These are the limits of integration. And the force function f of x is equal to x plus e to the minus x plus sine of pi x over 2. The units are in newtons, and the units of the limits of integration are distance, of course, as meters and 2 meters. All right, so the work integral is integral from 1/2 to 2 x plus e to the minus x plus sine of pi x over 2 integrated with respect to distance dx. Now we're going to apply U substitution in this part of the integrand when we're integrating e to the minus x, and in this part when we are integrating sine of pi x over 2. So you may recall the integral of e to the cx dx, where c is a constant, is simply e to the cx divided by c plus arbitrary constant of integration. So in this case, we're letting u be equal to cx. du is the derivative of both sides is c dx. And dx is equal to, solving for dx, isolating for dx is du over c. Du divided by c, and that's why we're dividing by c. We are reversing the chain rule. All right, so we have work is equal to integral from 1/2 to 2 x plus e to the minus x plus sine of pi x over 2 dx. Integrating term by term, what is the antiderivative of x? Reversing the power rule, we add 1 to the exponent and divide by the same. We get x squared, divide by 2. Reversing the chain rule, applying U substitution, what is the integral of e to the minus x? That's going to be e to the minus x divided by minus 1. Let's write it as minus e to the minus x. What is the antiderivative of sine of pi x over 2? Applying U substitution, we let u be equal to pi x over 2. So let me write this here. U is equal to pi x over 2. And du is equal to pi over 2 dx. And this is u sub, applying U substitution. So we're going to get integral sign is negative cos of pi x over 2. Divide by the derivative, divide by pi over 2. That's the same as multiplying by 2 over pi. This is reversing the chain rule. This is simply the U substitution method. All right, and we're evaluating from 1/2 to 2. Now we apply the fundamental theorem of calculus, put the upper limit in. 2 squared is 4 over 2, that's 2, minus e to the minus 2, minus 2 over pi. And we get cosine of, put 2 in, substitute x equals 2, 2 cancels with the 2 in the denominator, we get cos of pi. And minus, and put 1/2, the lower limit in, we get 1/2 squared is 1/4 divided by 2 is 1/8. Minus e to negative 1/2, minus 2 over pi, cos of, put 1/2 in, we get cosine of pi over 4. All right, so now cosine of pi is negative 1. Cos of pi over 4 from the 45, 45, 90 triangle, 1, 1, root 2 triangle, cos of pi over 4 is simply 1 over root 2. So simplifying this, we get work is equal to 2 minus e to the minus 2. Minus times minus is plus, so we get plus 2 over pi. Distributing the minus sign, we get minus 1 over 8. Minus times minus is plus, plus e to negative 1/2. Plus 2 over pi times cosine of pi over 4, which is 1 over root 2. And the units are, of course, in joules. We're in the metric system, the SI metric system. So let's talk about the U substitution that we kind of glanced over really quickly. So I want to go over that. Integral of sine of pi x over 2 dx. We're applying U substitution. We let u be the inside function. U is equal to pi x over 2. Differentiate both sides. We get du is equal to pi over 2 dx we solve for dx, we get dx is equal to 2 over pi du. So we get integral sine of u, because pi x over 2, that's our substitution, that's u. And solving for dx, we have 2 over pi du. 2 over pi is a constant, comes out, and we integrate sine of u. Integral of sine u is minus cosine of u. Now substitute u back in, and we get minus 2 over pi cosine of pi x over 2 plus c. I should really put a plus c here too, just to be accurate. All right, so this is just showing the step, the integration step for the integral of sine of pi x over 2, which is just a u substitution. But of course, the big picture is that we found the work done, and this is the work. There it is. Let me put that in a circle here. All right, thank you.